Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, ask me questions, let me know what you think about today's poem. Reach a number. So, as you know, I usually record these live and show me kind of go through the poem itself. This one was a tricky one. When I did it live, I think it took me more than half an hour. So you still can assess that if you go fast forward or skip forward, but I'm going to try to explain the algorithm and kind of the logic for this problem first and improvement as well before, because it was a very long process for me to do it live, and you can still see it. It's just that, maybe it's too long, but yeah. But for this problem, reach a number. So there are a couple of dots that I had while I was doing it. The first thing to notice is that target is going from -10 to the 9th to 10 to the 9th. So that means that if you try to do breadth first search, given linear time, O of n, it's going to be too slow because, well, n is 10 to the 9th. You don't even have memory for it because it's a billion elements, right? But the second thing to make an observation about is that target could be a negative number, which means you're going to the left, presumably, or right, depending. And without a loss of generality, you can just take the absolute value of the number because you can take the answer that you get from going to the right and then flip every direction and then go to the left and and then get the same number, right? But in the other direction. So that's why we have the absolute number. So the key part to notice for this problem, and it's a very hard problem for me, is that I just didn't know about this observation. And I would also say that these kind of observations and just knowing about these properties takes a lot of practice, and just doing similar problems, right? And and I mentioned this later in the video as well, where maybe a similar problem comes up on a contest and I solve it in 20 seconds, or like solve the observation part in 20 seconds. And then next thing you know, I get people asking me on stream or on Discord or whatever, like, hey, Larry, how did you know that to be true? And the answer that I usually have, and if you look at my recent contests where sometimes I do get these things quickly, the answer is usually I invested the time to solve and figure out these properties, before, right? And when you see the quote unquote the magic of something happening really quickly, it's because I've done it before, and sometimes multiple times before I learn it really well. So with all that being said, so I hope that that's a lesson that that there's no magic, there's no shortcut. You just have to do enough problems to kind of not even solve the problem, because for me, solving, looking at the answer or looking at the solution and memorizing it doesn't really, it's not that useful, especially for this problem, because it doesn't help you solve similar problems unless you put in the time to explore it. Okay. So the lessons on that level aside, and you could kind of watch me as I solve it live to kind of figure out the problem really slowly. So I'm going to skip a little bit about my thought process, because you could go toward the end and watch me do that. But the property that I did get today, and it took me like 20-30 minutes to kind of play around and try to figure out if it's true and prove to myself, even though I wasn't able to like I didn't have it initially, and I had to I wasn't convinced initially, so I had to convince myself that this is true, which is that, okay, let's start with a number, right? Let's say our target is equal to 25. Well, you have 1 plus 2 plus 3. Let's say you have some plus ... I think it goes to 7, maybe. Let me pull the number real quick. Yeah, 7, right? So this goes to 28. So this is the first number that's bigger than target. Well, you can't get there because if we flip the signs of any of these numbers, well, we know that because in order to flip a sign, what does that mean, right? That means that you subtract that number twice from 28, because once to remove it from the segment and then another time to change it to negative. And that means that it is impossible to get to from 28 to 25, because well, they don't have the right sign, right? You have to subtract 3. So then let's add another one with 8, which is 36. Let's put on another line so that it's easier to visualize maybe. Let me also make this font bigger, my bad. Now this is a little bit too big. Okay. So this is 36, which is still, have that problem of what we say parity, which is the odd evenness of the number. So then now when we get to plus 9, we have 45, right? Well, these have the same sign, so now we just have to get a plus 10. Or sorry, well, 45 minus 25 is equal to 20, right? And 20 means that we have to change, numbers that are equal to 10 here, right? And and you could see me kind of play around with this in the later video, but what happened was that apparently, as long as this number is bigger than this number, we can always, and they have the same sign, it's always possible. In this case, you just take, minus 9, minus 1, now you have minus 20, and you get to 25. And in fact, this continues being true, so you can actually keep on going as long as the signs are equal, right? So you get to plus 10. Well, there's a way to get there too, because this is the way. This is literally copy and paste. You cannot do it from 11 because now the signs are, 66, right? Or like 66, so now the delta, the difference is 41, which is odd, and you cannot get an odd, right? So yeah. Yeah, basically this is the idea. This is this minus 20, this is this minus 30. No, I think I messed this one up, but so for 30, you actually want 10 and 5. Oops. So I lied about that one a little bit. But yeah, but that's the idea, is that because you're building on these things, it is always possible, right? To construct it as long as the sign is correct. So from that, and this is not a easy property to understand or prove, definitely recommend playing around and figuring it out for yourself, as I did in the, like, you can watch me do it. I spent a long time doing this to kind of convince myself of this. So yeah. So let's say if you convince yourself that's true, then we can just do this algorithm, right? Which is that we start with step 1, which is, just one number, and then we keep going until we get to a number that's big enough and the signs are equal. And once we do that, we can return step, and that's pretty much it. So because basically that's just an implementation of what we figured out as the property, right? And we want the smallest number, so as the first instance that this is true, we return it. And that's basically how I solve this problem. What is the complexity of this, right? Well, it's going to be the square root of, so time complexity is going to be, for now, square root of target. And space is obviously all 1 because we just have a couple of variables. But me pedantically, I would say that the input. So when we talk about complexity in complexity theory, the n is the input size, right? So n is equal to input size, and n is equal to the number of bits, right? So that means that target is equal to let me put in another one. So that means that target requires n number of bits, and that means that in terms of that, right, the time complexity is actually O of 2 to the n, because for each bit you do, technically is 2 to the n over 2, which is 2 to the n. So yeah, that's all I have for this problem. Oh yeah, no, I have to remember to mention the binary search part. So this is how you do it in, square root of target time and O of 2 to the n time, right? However, what happens is that if you notice this, is that as you notice that there's a monoticity property to this, as long as it has the same parity, right? Meaning that if and you can also notice that every every two numbers have the same parity, because then after two numbers it gets added to an odd number. So you can check three numbers, but if you check three numbers or so forth, then that means that you can binary search on this, and you can binary search on this because of the monotonicity of the property of the problem, where okay, if it's big enough it's good, if it's too small it's no good, right? So what happens is that you're gonna be no good, no good, no good, no good, 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 right? So, and that is obviously a binary searchable thing. So definitely if you want to solve that as well. And then the other way to solve this, of course, is noting that you could actually just test the formula, because you have this, this is essentially n times n. Is it n minus 1? I always get them confused. Let me check. N plus 1, right? So this is 7 times 8 over 2, right? So n times n plus 1 over 2, which is a known formula, and from that you could invert it to get the answer, which is roughly like square, times 2 square root of that, right? And then all that is left is that you check a couple of numbers, because as we said, every third number, if you take three numbers, one of them is going to be of the same parity. So if you do that, you can actually even narrow it down from. So the binary search will have all of n times, where n is the number of bits. But if you do the square root method, technically it's all of 1 if you want to, because if you want to be precise, calculating the square root of a number is not 3, which is also log n, which is linear in terms of number of bits. But yeah, that's all I have for this problem. I gave you some solving ideas. Hopefully you got through it, because it took me a long time doing the actual thing, and even this explanation, it's a little bit long. Hope that's okay. Anyway, let me know what you think, because it's a very tricky problem, and that probably is really tricky to get, at least if you haven't seen it before. If you have seen it before, then maybe you're like, oh, this is obvious, this is trivial. But this is a pretty hard medium, because you have to do some mathematical proof, to at least to yourself, and also it is not a programming problem, it is a math problem pretty much. So take it as you will. Anyway, that's all I have for this problem. You can watch me solve it live during the daily stream next, and if not, I will see you soon, and take care. Hey everybody, this is Larry. This is me going over day 28 of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, ask me questions, and hope everyone's having a great week and going forward to a new year. So I do open and solve and explain these problems live, and the point of that being that I go through my thought process as I'm solving them. So if you just want to skip the solution, feel free to fast forward or just skip ahead, use technology. Anyway, today's problem is reach a number. So you're standing at position 0 and infinity number line. There's a go at position target, so you could go left or right, and then you could take n steps. Return the minimum number of steps required to reach the destination. That may be it. So we have to figure out the recurrence, right? Because given that the target is going to be basically within range of the int, that means that breadth first search or something like that is not possible, because that'll be too long. So the thing for these kind of problems, in a very generic or general sense, you do want to do breadth first search, because it's like in theory you're supposed to prove breadth first search is correct, but I mean like breadth first search has been proven, right? So like you should be able to do that, and you could do that. But for this problem, the key thing to notice is that you have to take n steps either from to the left or to the right, which means you're given some x and you add n, and then you can minus n, which means that there may be some sort of structure that you can take advantage of, right? And that's what we're going to try to figure out. And a couple of things that I am thinking of right now is it possible to go to zero or back to zero in a reproducible way? Like I know that, for example, 1 plus 2 minus 3 is equal to 0. And why do I do that is that in theory, we can later go back to, maybe if we could reset, then now we can take advantage of a later n. Don't know if that makes sense, or I don't know if that's a good answer, but maybe that's what I would think. But that means that you would need some, I don't know if that's possible beyond yeah, because I don't think that's possible, right? So if that's not possible beyond 1, 2, and 3, then the next thing I'm going to think about is how to make incremental progress. And how to take advantage of the fact that you're both going left and right at the same, possibly right? And of course, if you go zigzag, you're going to move one. Oh, so I guess that's a strategy to reset to 0. Is that you sig one way and then you sig the other, right? So that means say -1 plus 2, and then you go plus 3, -4, and then that goes to 0. So for every 4 steps, we can reset to 0, right? And why is that important? Well, that's important because then now we know a strategy of getting it, because that means that given a target number, what does that mean? That means that we could probably finesse it such that a lot of the smaller numbers even out. So let's say, I don't know if this is the right answer, but let's say we have 300, right? If we 300, then maybe we could consider a lot fewer possibilities, because we could get, I don't know, the first, not even aggressively, just say 280 to cancel out. Then we just have to consider, 281, 282, 283, ... right? And then, and maybe in that way you could have an answer to get to 300, just by the fact that you could +1 and then -1, maybe based on the parity of the numbers and so forth. But the problem with that is that for that, we're able to prove how to find one solution, but we're not able to prove how to get the minimal solution, right? So with that, we have to figure out how to do it in another way. And I know that I said like breadth first search doesn't make sense and stuff like that, and it's not, but it is not in a naive way, because does it actually? Because in theory you would in theory, if you do something in a greedy kind of way, I think the optimal answer will probably be around the square root of the target, or the square root of the absolute number of the target given as negative. And we can actually, without a loss of generality, you could actually just make it absolute value, because if it's negative, we have to go left, but by symmetry argument, you can just go the other direction, right? So we can actually do that without thinking about it too much anyway. I guess I thought about it a little bit. It's going to be something on the order of square root of this target, because that's basically because the sum of the first k steps is roughly k squared, on the order of k squared, right? So then the opposite of that will be square root of k. So that's basically the things that I'm thinking about. That's not the answer yet, though, unfortunately. And we've already been talking about 7 minutes, and I really don't have a clean strategy about it. And then the question is, well, if we only take square root of k steps, Can we buffer search? I still don't think so. Because you probably have to keep a scene state on a lot of numbers. I don't think there's going to be that much or that many gaps in terms of like if your hypothesis is that you could do a buffer search on a sparse graph where where the biggest number could be 10 to the 9, but there are a lot of spaces in between, so therefore the number of unique states are much fewer. I don't think that's the case. And then the question becomes, okay, is this a problem where you go right a number of times and then minus x and then go back left a number of times? And what I mean by that is that like, does it ever make sense to go consecutively left and then right? And I think maybe not, because that means that, because I think there's an exchange argument here, and I'm thinking off my head, so I don't know if that's true. And so if that's the case, you have, and this is just a hypothesis for now because I don't have a mathematical proof for it. So this is, let's just use K, or let's just use A. So first A steps is equal to this, and then you take another second B steps is equal to B, B plus 1 times 2. Maybe minus 1, I always mix them up. But then this, because this is actually the summation from A plus 1 to B. So it's actually this minus this. But this is the part that's a little confusing, because now they're moving in opposite directions. Is this minus this twice, if that makes sense, right? So you have something like do. So then this is just this minus A plus 1. Maybe off by 1, but and I think because of this formula, we should be able to iterate on A, which is the square root of the target, and then figure out B either by formula or binary search or something like that, and then figure that out. But I don't know if I'm convinced about whether this is true, to be honest. Let's see. But that would be a good square root answer. Wow, this is not an easy problem. I think someone mentioned that it is easy, but let me think whether there's a case where Yeah, I mean, I think this is roughly it, but I'm trying to figure out um, how to quite do it. I mean, I guess. All right, let me just do a brute force on this on B then. So yeah, okay. I mean, I'm gonna go up to target, but it shouldn't go that way if it goes that long because we should early terminate. But basically, what we want is we want B, and then we try to calculate A from the B. So okay, so that means that okay. Okay, so sum, let's say total is equal to b plus 1 over 2, and then square root, and then now we have an answer, square root times the, does that make sense? I don't know that I understand this form that well, to be honest. um, yeah, I mean, it is a math problem, so it's not really a programming problem. I'm just, I don't know, it is definitely not my strength. But okay, let's say I mean, I'm trying to, so the way that I would naively do it is also do an A in some range of total or something like, square root of total, say. But I'm trying to think about how to do it without it by some formula. I guess it's like roughly square root of n, but like we want to find some A such that A times A plus 1 plus total is equal to target, right? Someone like that. I'm trying to solve this. I'm trying to think in my head the formula that is in you know, the way to do it. But okay, let me think about this a little bit. Maybe this is a silly way. Okay, so let's say you have one. Let's see. I'm trying to think about a bigger number to practice on, but it's just 3 and 2. Okay, so let's say we have number, I don't know, 111, right? What does that mean? Well, you're gonna go all the way to, I think another thing that I could do is actually write I know that I said don't use breadth first search, but if you're really stuck like I am right now, you can actually write code to help you understand the pattern about it. So maybe that's what I can do here as well. But let's see, right? Okay, I'm just busting out the calculator. So we have 1 plus 2 plus 3. Maybe I should bust out a spreadsheet instead, to be honest. So like about 15, right? Maybe I need to, okay, let's take a smaller number, Larry. What are you doing? All right, let's say 25, right? I don't know if that's a good number. So this is 10, 15, 16, is it? No, 21, 21, 28. So I'm going to see if, and wait, let me double check that my number is right. Because that would be really silly, right? Okay, so it is 28. Because that would be silly. I've done this before where, okay. So 28, what does that mean? That means that in order to get to 25 from here, what do we do? Well, you can't just subtract 3 because that has a delta of 6, right? So if you subtract this, well then, okay, so here, now, yeah, if we do this, now we have a delta of 4. So that means that this is 24. And then we have to add 1 back, which we cannot, right? If we do here, then we have 26, which is too big. So we definitely need to, it's either that or we can, oops. So then we definitely need another number. So 28, what happens with 28? So this is 36, right? So we have to minus 11. That could never work then, right? Or am I messing up? Oh, well, no. Plus 9 will get us to. The reason why I said that could never work is because of the parity. Because yeah, because of the parity. And what I mean by that is because this is a even number, so you can't get to an odd number if you flip it. Because every time you flip a sign, you can only get another, like, it only, the parity doesn't change, right? So 45, that means they have to minus 10. Can we minus 10? Yeah. Oh, the minus 20, but 10 in total, which is 6 and a 4. Okay. So 25 should give us 9. Let me just run it real quick. I mean, I know that my code doesn't do anything, but I'm looking at the expected answer. Okay. So then my other guess, so the reason why I'm doing this, which I guess I definitely did not explain while I was doing it, to be honest, so that's my bad. The reason why I'm doing this is that I'm thinking that there's some kind of way in which you can always get any answer after a certain number. Because let's find another way, right? Which is that, okay, let's take this thing. So we subtracted 10. Okay. And then now we add 10 plus 11. This actually, so the plus 10 actually let's say 55, right? Then what can we do? That means that we need to get to 25, from 55, we need 25 difference, right? And 25 is not possible because as I said, if we flip the signs on these, it will be only a negative number or a even number delta. So then now we do, let's try 11, which is now 66. Well, why did, no, sorry, my bad. Let me go back for a second. Man, this is really late. So 55 minus 25 is clearly 30. Is 30 possible? 30 is possible. It should be, because we just have to take 15 in total, which is clearly possible, because you could just take the 5 and the 10, right? And that would be good. But we know that 9 is good, so that's true. Is it true that for... Now I'm trying to think whether it's true that any number after 45 is good, but I think that's not the case because of the parity. Because if you go all the way to 11, this is already 66, and 66 has a different parity than 25, meaning that you cannot get there, right? So then now we're trying to find this minimal number with the same parity. Okay, right? And we tried it with 7. What is this again? So this is just this minus 17. So that's not going to be an odd number, right? I mean, that's going to be, what, 28? I think we said that earlier. Yeah, okay. So basically, we want the first number for which the parity is the same. That seems like that makes sense to me, and you could do that in square root of target time. I think the proof that this requires is that whatever delta this number is, that you can get by changing these to subtractions, and you can always do that, I want to say, if they have the same parity, because let's see, right? You could do 1, you could do 2, you could do. Okay, so for from the number, if the delta is from 1 to 28, or sorry, 1 to 18, or 2 to 18, because we doubled it, then it's possible just by switching one number. That's trivially true. And then if it's more than that, then the bound would be 2 numbers, which is 34. Because if we flip these two, then we get. So what I'm trying to do is trying to convince myself, and this is what I do when I see a greedy problem or something that I'm exploring and not having the answer to, right? Or like having a past experience to draw back on, to be like, oh yeah, I know this is true because I proved it in the past, and that's how I know how to solve this, right? Which is something that for this problem, at least I haven't done in a long time. I probably have done similar problems before, but not this one in a long time, right? So what I'm trying to think of now is that for every, for every number smaller than 45 that is odd, we can get to, right? So let me maybe try a little bit with brute forcing a little bit, or like just enumerating, not brute forcing. So can we get to 1? So we need to subtract 43. Can we get 44, which is 22 square. 22. Can we get 22 from here, right? And that's just this, and this, right? Oops. Yeah, right. So this is possible. Good. How about getting 3, right? Well, this is just this, but now plus 1. What does plus 1 mean, right? Well, now the delta is. Did I mess up? The delta should be 24, not 22. My apologies for the viewers. But okay, so that's 12. So that would be just something. Actually, you could get. Wait. Okay, so the delta is 44. No. I was right. Sorry. Now this is 42. So that means that we have to change 21 total, right? And 21 total is also should be doable because that's just the same. It's just 5 plus 6 plus 10, which is 3 and 7. But basically, if you're thinking about it in terms of deltas, that's just, shifting this minus to a plus here, so that we're shifting it by 1. Can we keep on doing that? This is good because then now we can shift this minus 3 to minus 2. 7, this is good because we can shift this minus 2 to a minus 1. And 9, I know that I'm a little bit doing some exhaustive thing, but this is also minus 1. So here we can just shift this minus to minus. To be honest, I still am not 100% convinced. Because, okay, let's go backwards, right? Let's say we're trying to get 43. Well, that's trivially possible because, that's just -1. And then 41, well, that's just -2. And then we go all the way. So then now we have -9, which is 18 delta. So that means that is 27, right? And then now we want to do 25. Can we do 25? Yeah, sure. Let's just do another one. So then basically, in a way, is like a different based number system. And from that, you can exhaustively go through all of them. I don't know if I can prove that, but I feel like you can. I'm getting an intuition that you can figure it, and that any odd number under 45 we're able to do. So then now, having that, the code is actually pretty straightforward. I think you could probably figure a way to do an O of 1 with some magic math, but I'm going to do it the programming way, which is the square root way. So then now for step, let's just say, well, let's just go while true, because we know that it's going to run in square root of target time. So while step times step is I should say, actually, let's just do while true. So step is equal to 1, total is equal to 0. So then here we can do total plus step, step increment, and this is just prefix sum in a way. So I know that total is essentially, 1 plus 2 plus 3 plus 4 dot dot dot, which is equal to step times step, either plus 1 or minus 1. I always mess that up, over 2 or something like that. But I like to write it this way so that it's a little bit clearer to the expression of what I want to write. So I would recommend not over optimizing if you don't run into it, right? So anyway, and then now if total is greater than or equal to target and total mod 2 is equal to target mod 2, then we can return step. I think that's basically how I would want to think about it. Let's see if my, okay, off by 1. Oh, that's because I pre-increment. I think that's why. Because we want to increment step for next time. So I think that's maybe it. Let's try more examples, which is 3, 2, which are given. Let's try some big numbers. Is that too big? Maybe that's too big. No, that's 500 million. And the reason why we can try random numbers is because there is there's an expected answer, so we should just abuse it for now, and that looks okay. So let's give it a submission, unless I mess up on 0 or something like that. Okay, whew, this is a math problem through and through, and this took me about half an hour. Wow. So yikes. So the complexity is going to be the log of target, which is technically linear because target in number of bits has, n bits, and for every bit, oh wait, no, this is square root of n, not log n. Sorry, my fault. This is square. So this is square root of n times, which is linear time. What did I say before? No, is that right? No. This is 10. Okay. Let me say it again. Sorry, I confused myself. So people would, you may see in the forums or something like that, I haven't read it yet, that people would say this is square root of target time, which is technically true, but to be pedantic, the complexity is usually measured in the size of the input. And here the size of the input is an int, meaning that it's an int representing target takes log of target number of space or bits to represent. So for n is equal to log of target, this takes square root of n, which means that this takes the square root of I think I mixed up the signs again, but I think technically this is exponential is my point, but this is exponential in terms of the number of bits. It's going to be like 2 to the n over 2 if you want to call it that, but which is obviously just 2 to the n, which is not commonly phrased because people think about it in terms of the input number and not the input bit size, which is why it even stumps me from time to time. But yeah, and in terms of space, obviously this is just constant space. We only care about steps. So yeah, so going over it again as a final thing, and I probably usually will record it over. But yeah. Yeah, I think for an extra bonus, I'm going to read the solution because maybe there's an easier solution that I don't see, but definitely this was a struggle for me because, but I think also just as a maybe meta lesson is that these are the things that when you explore these type of problems, if you're able to kind of really play around with the problems, you're able to figure out properties. And for me, it is me thinking about the properties that I drew pictures for, but I guess I did. Oh, there we go. These properties are are things that if you really do spend the time to explore these and really think about, how these things work, in the future when you see a similar problem, you'll be able to, you still have to, like, other people might ask you, like, why do you know this? And maybe you'll be like, oh, either I know it or I've done similar problems before and I explore this. This is what they mean when they tell you that, right? And it's not that, maybe you watch another video that I saw, a week from now, and it's similar, and I go, oh yeah, summation of the first 6 numbers. All you have to do is blah 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 blah, and and I'm able to get it instantly. And that instantly is what you don't see in that instantly is that I spent half an hour, in this case half an hour, but in other problems sometimes 2+ hours, try to figure it out and learn from those problems. So that's maybe a little bit on a meta lesson, and I hope that y'all, when you try to work out these problems, and when you see someone who quote unquote is good, it means that they've done those problems and explored those properties before, and that there are really no shortcuts, and you have to really just have to put in the work. That's one comment that I would say. And yeah, and after this, I do want to take a look at the solution just to kind of see if there's maybe a easy solution that I missed, which is possible. So I'm just going to take a look. There's a mathematical approach apparently. Let's see. The crux is when target is less than 0, and we made a sum of target. We could just switch the signs, of course, because I actually even used the same wording. I said something like, without loss of generality, we can use the absolute value, because you can just go, going left is the same as going to the right, but the negative, right? So, so we can do that. Now let's say, oops, S is target. We'll change some number sign. If delta is, we can. Oh, I see. Maybe that proof is clearer to them. It definitely took me some time to prove it in my head, but the parity is still the same. Okay. Oh, this code being pretty much the same as mine, maybe. Well, I think I checked the parity, so yeah. And again, they did the same thing that we were talking about, where they called the time complexity as being the square root of target, which is, I guess, technically true, but not an O(n). Oh, there's no. Why did they say approach 1? There's no approach 2. I also agree that this is not an easy problem. Is this rated as easy? A medium? Okay. But this is definitely, even for a medium, I think this is very tricky. And I think maybe you're able to get this if you have done a similar problems before, and you know this property of the summation of the first k numbers, which I don't know that I would say is a proper expectation, because I had some sense about it, but even then I had to like play around with it to get that property. So I think that's a really weird problem. Yeah, that's all I have for this problem. Let me know what you think, and hope everyone had a great night, and I'll see you later. Bye bye.